So today we will continue the Terraform uh, topic. Okay. So in previous section we set up a EC2 mission, right, using Terraform. Previous class using Terraform we deployed EC2, right? So today we will today we will deploy uh, like a VPC, okay, from scratch. Then the VPC components. What are the components for a fully functional VPC? That all the components we need to include inside the VPC, like internet gateway, subnets, route table, route subnet association. Yes, these are all the things that we include in the VPC creation. Then after that, we need to deploy yeah, EC2 mission, okay, using Terraform, EC2 creation. Third one is we install a web server installation. And finally, fourth one is deploy a sample application. Okay, so these are the things that we include in the section using Terraform. So the entire process here we use Terraform, okay, for deploying VPC, CC2, web server installation, sample application deployment, everything we perform using Terraform. We didn't go to AWS console or do anything manually, okay, like previous, like at the first time, you remember we deploy some sample application. The way we go, like go to console and provide that info for creating EC2 machine. Then after that, we log into that machine. Then we install Apache. Then copying the code from directory to the corresponding directory like that. So today we didn't do that. Only we perform using Terraform. Got it. Anyone have any doubt?
No.
So yes. need to do for doing this using Terraform? Can anyone explain? You need to write the Terraform code, right? Terraform code for VPC. First one VPC, right? Terraform code for VPC creation. So then second one, here we need to mention that VPC name, okay? Then VPC IP address. How we manually creating VPC? The same way, you need to provide the information, okay? Like the name, IP and everything. When we go into the code, then we go with the creation of subnet. Again, we need to provide the subnet name, okay? And which which VPC that we are going to use this subnet. So we need to provide that thing. So manually, you remember when we creating subnet, first we need to select that VPC, right? Which VPC that we are going to use this specific subnet, okay? So the similar way, we need to mention that when creating this specific subnet, we need to provide the corresponding VPC. Then the subnet name, subnet IP, and the zone where the subnet belongs to. These are all the things that we need to provide as code. So the third one, internal gateway. So coming to internal gateway, we need to create internal gateway and attach to the VPC, right? That's the thing we manually perform. So here we need to create a internal gateway, then give internal gateway name. Then we need to mention, okay, that VPC, which VPC that we are going to attach this internal gateway. Then route table. This route table for this specific subnet, okay? We created this route table. So here we need to mention route table name, then the which VPC. Okay, so we need to mention the VPC name, then the routing. Okay, here one of the main thing is coming to route table. First, we need to associate this route table. Then we need to add the routes, right? For example, in this case, we need to make our subnet. I mean, this subnet we need to make it as public. This is a subnet, and we need to make public. After that, we deploy the EC2 within the subnet and deploy the server. After that, we expose the EC2 application, right? So we need to make the subnet public first, okay? So that all the things we need to provide in the route table, like we need to add the route. We need to mention that IP address like 000/2 internal gateway, pointing to internal gateway. Then the fifth one we need to associate this this subnet, sorry, this route table with the corresponding subnet. Okay, so we need to create a route table association. So in that association, we need to provide that we created a route table association. Then we need to provide that subnet, which subnet that we are going to associate with the table. Then security group. Sixth one is security group. So coming to security group, like when we go with the manual way, we didn't create any security group. We go with the default one that Amazon offers, okay? Because there is a default security group when creating EC2 machine. So in this, otherwise we can create a security group and enable the ports or disable the ports. Okay. So in this case, I created the security group and opened some ports because this is for accessing. I mean, our final output will be we need to expose some application, HTTP application. So we need to open the port number 80. Okay. So in coming to the security group configuration, you need to open the port 80. Okay, for the incoming traffic, only the incoming, and for the outgoing egress traffic, we open all the traffic. Okay, all traffic only for outgoing. Okay, from the EC2 to the internet. Then the seventh one is uh, the configuration of EC2. So we need to provide that mission name, mission type, then the which subnet that we are going to deploy, then the VPC, I mean security group, we need to provide the security group, then the key name, everything we need to mention under the EC2 configuration. Also, I used a user data, okay? User data. User data is we can go with the manual, okay? Manual deployment also we can provide a user data. That data we can attach to the EC2, okay? So what will happen when EC2 loading? The user data will execute, okay, after the boot. EC2's boot after, I mean, the machine turn on, then it's looking for the user data. Okay, if we provide the user data, so inside the user data, we can add that commands. Okay, the commands for installing web server. Okay, so apt. So I mean, yum install HTTP like that. We can provide all the commands. So in this case, I added a lot of commands to install the web server, then exposing the application as well. So all the data I provide under the user data. Otherwise, we need to, I mean, after the deployment, after the configuration of the EC2 by Terraform, we need to log into that machine, then we need to perform the same. Otherwise, we can use the user data. Okay. So that's all. And finally, the Terraform will expose the output of this EC2 machine public IP. So we can just copy the public IP and using that IP in the web, web browser. Okay. So we can see the application. So these all the things we use IAC, infrastructure as code. Anyone have any doubt?
How is this connected to the concept of Jenkins? I mean, Terraform helps you create the infrastructure,
Yes.
but Jenkins is helping you deploy everything, right? Correct version across everything.
Mm, No, no, no. Jenkins is CI/CD tool, right? I mean, both are different tools. We can integrate both using, for example, we have these. I will explain, please.
Is Jenkins aware of the what the infrastructure is made?
No, no, no. I mean, we can leverage Jenkins here. For example, in this case, what will happen? Okay, I mean, we created all the Terraform configuration, and this is our laptop. All the codes are here. Okay, the codes are here. I mean, the Terraform code. Yes. So we need to push this to AWS, right? AWS. We already connected a service connection. Then we pushing the code to from our mission to the AWS. So the Terraform will build everything. Okay, what are things that we include in the Terraform file? So this is one way. So using Jenkins, okay, using Jenkins, we didn't keep this code here. We keep this Terraform code in a repository. For example, this is a Git. GitHub. So under the GitHub, there is one directory, so we can keep that Terraform code there. Then we created Jenkins. Okay, we need to create a job. So coming to the job, we need to provide that repository URL, okay, where the Terraform files belongs. And here we can add some trigger something, okay. Like trigger means Terraform apply, Terraform list, a lot of uh, jobs are there, okay, under the specific project. So whenever we go with the the apply or destroy, what will happen? Jenkins will looking for the code and take the code, and it will deploy to the AWS account. This is the AWS. So we need to configure everything. So this is called a CI/CD using the same application. For example, next time we need to add one more mission. So what we need to do? We just open that Terraform configuration file using GitHub, or we can use from the local machine as well. Okay, so this local machine connected to GitHub. Then here we can keep the code. So we need to add something in that existing code, then push to GitHub. So the Jenkins know something added. For example, this existing data is one EC2. Okay, so here we added one more EC2 for the same location, like same VPC or subnet. So Jenkins will taking the code and deploy the another machine. Like now we can see two machine running. Got it. I'm all.
Yes, so Jenkins basically looks at the Terraform file and accordingly deploys the correct infrastructure.
Yes. This is
Okay.
automating using Jenkins.
I remember that there's some way in which you use these two together.
Mm.
This is what you explained, yeah.
Yes.
Thank you.
Yeah. So we can go with the lab, right?
Yes. I have to leave a little bit early today.
Okay. Okay.
I will try to rejoin later if it's still going on. Otherwise, I'll watch the video. Thank you.
Mhm. Yeah. So I am going to use a folder. Okay. So just open a folder in my Visual Studio Code. So I selected the folder called VPC. So uh, we can include all the Terraform files under the same folder. Okay. So here we can add files. So I'm going to add one files under the same folder. So click on that and name it provider.tf. So this will be I need to I mean to provide that which provider that I'm going to use. We can copy the Terraform provider block from official Terraform registry. This is the code, okay? Just to copy. So we successfully added a Terraform block, okay, block for provider. So the Terraform know that we are going to use AWS cloud provider for this configuration. So after added that config everything, okay, like adding any files or any commands, we need to save, okay, for pushing. Then after that, we can try to connect with the AWS, okay. I think I already connected with the AWS account. Yes, it's connected. That's why it's showing the previous connection. I mean the access key and secret key. So we can leave it as same. Otherwise, we need if you have any new one, then we can specify here. So everything is same. Then we can go with the Terraform commands. Terraform init. It's actually initially listed. Okay. So everything seems good. So now we didn't have that configuration file. Only we provide the provider.tf. So we need to build the infrastructure, okay, using code. So we need to create another file like main.tf tender. So here we need to add our configuration file, okay. So I added a block. This is actually called a blocks, okay. So coming to Terraform have I mean, we need to create different resources, right? So each resources we need to keep under different blocks. Okay. So you can see here the resources. This is actually a keyword. Okay. This keyword we going to use to specific services. Okay. In this case, this is a block. So first we need to use a keyword resources. So which resources that we are going to deploy. Okay, so in this case, it's a AWS VPC, and this is actually like a resource type. Okay, so in this case, the type is a VPC. So this is predefined value actually. So that AWS knows this is going to create a VPC. So this is predefined value. So we mentioned that we need a resource that is AWS VPC. So that we need to mention the type, okay, resource type. So when coming to resources, resource type, then we need to mention the resource name. Okay, this is actually the resource name is actually a label. Okay, like for example, this label should be unique inside this Terraform configuration, and we can take that the label when selecting other services. For example, we created a AWS VPC. Okay, so next we are going to deploy. I mean, we need to create another block for creation of subnet. So we need to identify the VPC, right? For example, uh, under the when creating subnet, we need to choose which VPC that we are going to um, use for this specific subnet. So how we identify that VPC in Terraform code using label. So the label should be unique in AWS. I'm sorry, the Terraform. Okay. So the first block is fine. Then we can, yeah, now it's created. Okay. Sorry. Now the VPC part is done. And also you can see the CADR block, which IP that we are going to use for the specific VPC. That is this 10 dot series 10.0.0.16. Then under the tag, we need to mention the VPC name. Okay, so this should be the VPC name. Okay, whenever we can see that VPC in dashboard. Got it. So this configuration is we call the configuration settings that we define within the block. Okay, so this is a resource, then the resource name and the resource type and resource name as label. Got it? Any doubt? Anyone? Fine, right?
Yes.
Okay. So the next block, see, the next block is subnet creation, right? So again, we need to provide the resource, okay, that which resource yet we are going to create. So the resource type is AWS subnet and the resource label name is main. Then this we can change. Okay, we can leave it as same. So now you can see the VPC that we need to specify, okay, for the subnet. So see AWS VPC. Okay. So when we select the AWS VPC, you can see the resources we already created about AWS VPC and main.id. So main.id means that VPC have a label here, main. So what will happen? The subnet will under the VPC that we already created above. And also we provide that CADR for the subnet creation subnet. So that should be 10.0.1.0.24. Then mapping public IP on launch. Okay. This means whenever we create any app, any resources like EC2, so the EC2 have public IP. Okay. So we make it as true. If we make it as false, then that subnet doesn't have a public IP. Then the availability zone, okay, for for the subnet, so that we need to mention here USC is to 1A. Then the name of the subnet, that is a sample subnet. I'm changing to public subnet, okay. So anyone have any doubt regarding the subnet? So for next resources, okay, we created a, I mean, we provided the details data for VPC creation subnet, okay. So next one is we need to create a internet gateway for internet connection for the VPC. So we need to create another resource type, that is internet AWS internet gateway, and provide the name. Here I am provide the label. Okay, the label type is main. Then the VPC ID. VPC ID. How we connecting this instance? I mean, sorry, this internet gateway. How we attaching this internet gateway? So here we provide the VPC ID. So whenever it's created, that this inter gateway will attach to the specified VPC. Okay, here we've specified VPC, that is AWS VPC dot main dot ID. This ID looking for that VPC name with the main, the label. Also the tag name, okay, like the name for the resource internal gateway. So I change it to internal gateway. That's fine. So next thing we created the subnet, right? So we need to create a root table, right? So that this is a root table block, okay. So again, we need to specify, provide that resource, creating another resource called AWS root table. Then the VPC, which VPC that we are going to use for this root table. So we need to mention the same thing, AWS VPC dot main dot ID. Then root table. This is a routing actually, okay. This is called configuration settings under the resource, okay. So here we need to provide the routes from, this is a destination, okay. Sorry, this is a target actually. The target is internet connection, right? That why we provide 000. This is the way how we adding the routes, you remember. And this pointing to destination is gateway ID, internet, AWS internet gateway, main dot ID. That means we above created a internet gateway. See, and the internet gateway label is main. So this will point into that internet gateway. So that means our subnet is public. So the next thing is we need to add that subnet association. This is a block for subnet association. So the resource AWS root table association. The type is main. The subnet ID, we need to provide a subnet ID. Okay, which subnet that we are going to use. So this is subnet ID, subnet.main.id. Then root table ID. So we need to provide the root table. Okay, root table name here. Okay, AWS root table.main.id. So this will ensure that our subnet is successfully associated with the root table that we created above. See, this is a root table. Now we need to create a security group, okay, separate security group before deploying the DC to machine. And we can use that security group, attach that security group for the instance that we are going to create, okay. So I added that security group info here. See, resource, AWS security group, the security group label name. Then we need to mention the VPC ID and ingress. That incoming traffic, okay. I only opened the port number 80, that is allowing for HTTP connection. So anyone can access, okay. See, using protocol TCP. Then egress. This is outbound connection, okay. From the instance, from the instance to the internet. So we opened all the traffic we opened here. And also we created we mentioned a name for the AWS security group, that is WebSG. That's the name. Then we can go with the creation of EC2. Okay. So then this is a EC2 block. Here you can see resource type. Again, we need to mention then which type that we using. So the resource is AWS instance. The tag name, sorry, the label name. Okay, that is web, and we need to provide the AMI. So this is the AMI. Then instance type T2 micro, subnet ID. Above we created a subnet that is labeled with the main.id. So we need to mention that here. Then the VPC security group ID. So above we already created a security group. So this is a security group ID. Then the key name. This key name means the key for accessing this EC2 machine. Okay. So in my case, I have an existing key. So I provide that existing key name here, my name, my new. And here I mentioned that public IP address that is true. So uh, that when we creating, you remember, like we need to enable the public IP, enable or disabling. So this is a way of enabling. So we will get a public IP, okay, whenever the machine is launched. So this is the user data, okay. So coming to the user data, what we perform, like we provide all the commands when after the boot, okay. So after boot, this EC2 machine looking for any user data. If there any user data, then it will execute, okay. So this is actually a script, so a small size script. So the first command is this one, okay, yum update. This is for the updating the package manager. Then the next one is installing HTTPD. This is a web server, okay, Apache. Then we need to start the Apache, then enable the Apache. After that, we print out something, okay, using echo command. We created a small script, a small HTML here. See HTML H1. So this is a content hello Terraform HTTP server. Then closing that HTML. Then it write out to the path where var www.index.html. The path of that is in web server. Okay. So that after that is ending that script. So we added a tag name for that EC2 mission. The mission name should be like sample web server. The last one is output. Okay. So after completion of EC2 creation, Terraform will display that IP. Okay. The IP means the public IP of our instance. So EC2 public IP, the value here you can see the configuration settings. Okay. The value AWS instance dot web dot public. So what will happen? This output looking for the EC2 machines that is belongs to web. Okay, here you can see the type is web, and it will take that public IP and display in Terraform. Got it? All of you. Anyone have any doubt?
So from where we were copying all these codes for the blocks?
This is in my notepad actually. So
Okay,
I
so
keep
in real
small.
time, if yeah, I got it. But in real time, if we want to do that then from where we can take it, like
We can build from scratch, or we can using some
anyways,
nodes.
we have to keep it safe, right? In that case,
Safe.
like whatever save, like we'll just save it whatever you will provide us. So
Yes, coming to organizational perspective, they have there are templates there. Okay, so we need to customize as per the requirement. For example, some existing templates there for specific services. For example, this is the way we need to provide the machine configuration, right?
Right.
So the I mean, the user data should be looks like other things like for Nginx or any other application deployment. So the
Okay.
instance ID is not related to this one. This is actually a T2
This
free
is
tier machine.
like
Okay.
you have created. So
Yes,
yeah,
we can
yeah,
change the micro. Similar way we can adjust that things. Okay.
right. But the format will remain same,
Yes.
the way it
Right,
has
right,
been
right.
written. Okay.
So we can go with the Terraform plan. Okay. To save. Okay. Whenever we add in any code, we need to save. Otherwise, the Terraform doesn't look for the added things. Okay. After save, they will add. Okay. I mean, Terraform will looking for. So here you can see plan 7 things that we are going to deploy. So everything we can see here. Okay. This is actually a preview that these are the things that we are going to deploy like that. So the VPC, subnet, security group, everything we can see here. Okay. Route table association, internet gateway. So the plan command is done, then we can directly apply the changes. Apply. Yes. See, it's creating a VPC. Okay. So same way we can, yes. So the VPC creation is done. Route table, security group, subnet, everything is creating. Okay. Now it's instance creation. Check, okay, the machine is listed here or not. Yes. See how fast is created everything like the VPC. Otherwise, how much time we need to spend like from the VPC to AWS, I mean EC2 mission application deployment. Here, see, it's completed, 7 resources added, and it will show that IP, the public IP of that EC2 mission. How much time it will take when go with the Terraform? So you guys see the difference, right? The manual way and using Terraform. This will take some time, okay, like accessing, I mean, exposing the application because the machine is booted, right? After that, that user data will run, right? Step by step process like updating package manager, then installing the Apache, everything. So it's also created a VPC, okay, which our VPC name is sample VPC. So we can go VPC. So this is a VPC we created, okay, now sample VPC and subnet, public subnet, I think. Yeah, this is the one, this one. root table, sample root table. This is one. Internal gateway. This is one. Then, yeah, you check the application. Okay, now it's live, I think. So all the resources, okay, what are the resources? Around 7 resources we created using Terraform. It will take, I think, less than 1 minute, right? Can anyone check this IP address? I think that's the application is exposed. Okay. In my mobile, I can see the application, but in browser, some issues there. It's accessible, right? Anyone can try.
Sir, it's working.
Okay.
It says hello Terraform something.
Right.
Yeah, hello Terraform HTTP server.
Yes, it's working here also. See. So these are all the process using Terraform. Okay. So one more thing I will show you. Okay, how quickly we can destroy everything. Okay, that we created. So from the VPC to the EC2 with a single command. So what's the command? Terraform destroy. So this command ensure that we created the entire infrastructure using Terraform will destroy, okay, within a single command. And we can hit enter. So the termination, I mean, deletion of these resources within a couple of time, okay, like within 1 minute, I think. No need a 1 minute, it will destroy everything. So this is a asking for an approval, okay, just hit yes and hit enter. So it's deleting, destroying everything, okay. Otherwise, how we manually deleting everything? You just assume like we need to go to the VPC, then go to select the VPC and delete. Then we need to go to internal gateway, subnet, root table. It's a time-consuming process when we go with the manual. This is destroying in reverse way. Okay, first is destroying the one that created last. So coming to destroy the first, destroying the created the last one. Okay, from the web server to the VPC. Last it will go to the destroyer of VPC. It's a reverse. See, it's destroyed seven. Seven destroyed. That means uh, all the resources created by Terraform is destroyed within less than a minute. See, the machine is this thing. And go to the VPC. Before, I think it's five VPC there. Now we can see how much, how many. See, that sample VPC is gone. Similar way we can see, yes, that subnet as well. So gone. Yes, nothing is here. Everything is destroyed by Terraform. Got it. Anyone have any doubt? So this is a way we created the entire infrastructure from scratch using Terraform. So as per the requirement, we need to specify corresponding resource type. Okay. So in this case, the what are the resource types that we use? VPC, subnet, EC2, security group, lot of resources are there. Okay. So coming to AWS, AWS have lot of services like a lot of services are there, right? So we need to specify the service type as resources in Terraform. Got it. All of you. Anyone have any doubt?
Not right.
All are fine, right?
Yes.
Okay. Then Pooja, you face the same issue right now, right? Could you share the screen?
Yes. You need to close and share your screen first.